we're going to look at finding determinants. Now, a determinant is just a number that is associated with a matrix. And when we're trying to find the determinant, we'll write it with these vertical lines, so it almost looks like the absolute value, but it just means find the determinant of A, so it's just asking to find a certain number. Now, the determinant of any 2 by 2 matrix is found by just multiplying the diagonals and then subtracting. So it's going to be AD minus BC. And so that is, we would write it with those vertical bars and say that it's whatever that number AD minus BC is. So I'll give you a minute. You should pause. Try number 1 and 2 to find that determinant. So now that you tried, let's check. We're going to use our notation, the vertical bars. So that says the determinant of A. And that's going to be equal to 12 times 4 minus negative 2 times 3. So that's going to be 48 minus negative 6, which is 54. So 54 is the determinant of matrix A. For number 2, we have the determinant of matrix B will be equal to, we'll do 3/8 times the 4 minus 6 times the 1/3. So this will be 12 over 8 minus 2, 12 over 8 dividing by 4, I guess. That's really 3 over 2 minus 2, but that's really 1.5 minus 2, which will be negative 1/2, or negative 0.5. So we found the determinant of a 2 by 2 matrix, but then how do we get to larger matrices? So we're going to look at an n by n matrix. And so we're going to try and relate this to the 2 by 2. And the way that we do that is we're going to try and find these things called minors. So the minor, and we have some notation here, that's the ith row and jth column, is found by deleting the ith row and jth column. So let's see an example what that means. So for a minor, if we're going to look at the first row, so here's my first row. If I want to know the minor associated with like the negative 2 here, we're going to cross off the row and the column. And so I'm going to do that over here. So this guy cross off row and the column. So that leaves the 8, 2, negative 1, 0. And so what we just found is the matrix by crossing off the row and the column, and now we need to find the determinant of that. That's what we call the minor. So minor for row 1, column 1, it looks like an 11, but it's row 1, column 1, will be that. So we'll cross multiply, 8 times the 0 minus 2 times the negative 1. That 0 really plus 2, so we get 2. So now for the next element in that first row, because it wanted me to find the minors for each element of the first row, I'm going to look at the 4, so I cross off the row and the column. So the matrix will be 1, 2, negative 3, 0, but we're going to try and find the determinant. So again, diagonally, that's 1 times 0 minus 2 times negative 3. That'll be 0 plus 6, so we'll get 6. So then we're going to find the minor associated with the 3. That'll be leaving the matrix 1, 8, negative 3, negative 1. And so we will find the determinant here. That's 1 times negative 1 minus 8 times negative 3. So we're going to get negative 1 plus 24, which will get me a 23. That's the minor associated with that 3. So I guess I could have named these. For the second one, this was M, and it's going to be row 1, column 2. And then this one would be row 1, column 3. So those are the minors associated with each of those elements. And so what we're doing is, or what we're going to be able to do, is use those minors to find a determinant for larger matrices. So in particular, we're going to look at a 3 by 3 matrix. And so the way that you find the determinant is a bunch of little 2 by 2 determinants. So what they did for this little definition is they found the minors associated with this column. And so you can see that each of those elements, there's A1, A2, and A3, and then what's next to them is the minor associated with them. So if I cross off row B1, column 1, that's where A1 was located, you can see the B2C2 333, B3C3. Now, if I erase all that, if I look at the minor associated with A2, so here's A2, cross off the column, row, you can see the B1C1, B3C3, which is right here. And lastly, erase. If we look at A3, the minor associated with that, we have B1, B2, C1, C2. That's exactly what's here. So you can see they're multiplying each of those minors by the element that it's talking about or associated with it. And then the other thing that happens is they subtract the middle minor. And so there's a sign pattern that happens dependent on which row or column that you use. So if you use the first column, the first minor is positive, then we have negative, then we have positive. Now if you choose a different row or column, again, you got to pay attention to the sign. So when you look in here, if you were going to do it about that first row, it would be a plus, minus, plus. So almost all the time it's plus, minus, plus, unless you're in the inside portion. And a quick way to remember whether you should be positive or negative is really based off of, we'll see it right here, if the sum of the row and column number is even. So this is A1, 1. So 1 plus 1 is 2, it's even. This is A1, 2. 1 plus 2 is 3, it's odd. So you can see why that's minus. This is A1, 3, 4, even, we get plus. So anytime it's even, we're going to have a positive. If it's negative, that's what we were just seeing, it's odd. So this would be A1, A2, column 1, A2, 2, A2, 3. This would be A3, 1, A3, 2, A3, 3. So again, when its location is even when you add, I kind of show you, all of these guys have even row and column number, and so they're all positive. The other guys, they're odd, and so you can see that we're going to put negatives in there. So let's see, let's try and do that. So to find the determinant for number 4, you can pick any row or column that you like. I'm kind of drawn to one that has a 0 in it because then that would just become a 0. So if I'm looking at the last column here, I'm going to expand by minors. So I have 3, 2, 0. And now as I look at that, I'm like, wait a minute. We actually just saw this matrix a minute ago, so I'm not going to do 3, 2, 0. You totally could. But earlier, we found all the minors of this matrix based off the first row. So we can use that. So we already know, again, based off of that first row, I kind of cheat a little bit here. So I'm going to do -2 times 8, 2, -1, 0, the determinant. Then I'm going to do 4 times 1, 2, -3, 0. So row, column, and then row, column, row for the last one. So that will be a 3 times, what did I just do? Let me erase that really quick. So for the 3, you cross off. There we go. So that's 1, 8, -3, -1. So those are all of the determinants times their associated element. And then paying attention to the signs. Again, that first entry, that's a plus, a minus, and a plus. And we say minus, we actually are just meaning opposite. So if it was already negative, it turns positive. And when we say plus, it just means it stays the same. Same sign. So I'm going to keep the -2, that stays the same. This is going to be opposite, so that will become a negative, and then that one stays the same. So that actually has a plus in there. Now we calculated those quantities already, so I'm going to go over here, and I already know that this determinant here was 2, this determinant was 6, and this determinant was 23. So again, just based off of what I found earlier. So then to actually find the whole determinant of the 3 by 3 matrix, it's just going to take that -2 times 2, -4 times 6, and +3 times 23. which will end up being, let's see, we got -4 minus 24 plus 69, which will equal a positive 41. So 41 is the determinant of my original 3 by 3 matrix. All right, so number 5, I see this one would be really nice to use the third column. So again, this one we haven't found any of these minors yet, so we'll start here. And so I'm going to start by writing out the elements. And I'm also going to write out the signs too. So again, this first guy is in first row, third column, so that would add to 4. So that's a plus, that would mean that's a minus, and that's a plus. They alternate. And again, plus just means keep the same. Minus means do the opposite. And plus means keep it the same. So my numbers, 0 is going to stay the same, 4 is going to turn into the opposite, so that'll be a -4, and then 0 stays the same. And so then I'm going to write the minors. So for the first 0, the minor would be 3, -7, 5, 9. Find that determinant, which that's just going to become 0 because my term here is, or my entry is 0. For the next part, I'm going to cross off the row and the column. That leaves -8, 12, 5, and 9. And that will require a little bit more work. And then lastly, the last element there, crossing that off, it's going to leave -8, 12, 5, and 9. But again, this one's really nice because it's just 0. And so all I really have to calculate is this little one determinant. So that will be -8 times 9 minus 12 times 5. And I'm going to multiply that by -4. So I have -72 minus 60. -72 minus 60 becomes -132. We'll multiply that by -4, which will be 528. So we're looking at 0 plus 528 plus 0. That's equal to 528. That's the determinant for that 3 by 3 matrix. Now, if I did it on any other row, I will get the same exact number. So you could try that again. Try maybe the first row and see what you get. It should all come out to be 528. Now that expands to even higher or bigger sized matrices, like a 4 by 4 or 5 by 5. You can still follow that same method. But for a 3 by 3, another way to do it is by using the method of diagonals. So if you liked how if you have a matrix that only has 2 rows and 2 columns, if you want to find that determinant, ABC, that should have been a D, you just cross multiply AD minus BC. If you like that feeling, we can set up a 3 by 3 matrix to kind of do the same thing. So in a forward direction, we have that positive. Backwards direction, we have that negative. So let's see what I mean. So they say that you can recopy column 1 and 2. So if I'm looking at this example here, I'm going to recopy column 1, -8, 3, 5, and column 2, 12, -7, 9. And I just want to point out that this is actually the same matrix that we found down here, the determinant to be 528. So we should get the same answer. I'm going to keep that in mind, 528. So I recopied column 1 and column 2. And I'm going to kind of draw the line so I know I'm finding the determinant. Okay. And so it wants me to do some diagonals. So it says multiply the elements on the diagonal, begin in the upper left corner. So that should sound really familiar. Upper left corner. We're going to multiply those. And that's just what we did with our 2 by 2 determinant. Looking up here, 2 by 2 determinant, we would multiply those guys together. Now this time, because it's a 3 by 3, we have a few things to multiply. Those guys and those guys. And so we're going to multiply all those 3 guys. And then we're going to find the value of the determinant by adding those up. And then we're going to subtract. Again, this should seem familiar. Subtract off going the other diagonal way. So we're going to have to multiply. Remember, there's to be 3 things in a row. 3 things. There we go. We're going to multiply those together and subtract them. So let's first do the blue. We have -8 times 7 times 0 plus 12 times 4 times 5 plus 0 times 3 times 9. Then we're going to have to subtract, and let's see what I have here. I'm going to write it as like one big chunk of stuff because we're subtracting that whole thing. We have the first diagonal here, 12 times 3 times 0 plus negative 8 times 4 times 9 plus 0 times negative 7 times 5. So let's see what this looks like. This will become a 0. This guy right here, we have 12 times 4 times 5. That'll be 240. And then we have 0. Now on the other side over here, well, that's a 0 and that's a 0. So then right here we have negative 8 times 4 times 9, which will be negative 288. So the big mistake that I see is people do some kind of weird things with subtraction. But what I like to do is I find out the whole total of the first weighed diagonals. So I have 240. Then I'm going to minus the sum of the other diagonals, which is negative 288. And so if I add those together, that's actually 240 plus 288. But 240 plus 288 equals 528, which is exactly what we got using the other method. So when you're asked to find a determinant of a 3 by 3 matrix, really could do either way. I kind of like the diagonal way. Some people like the minor way. It doesn't really matter, whichever you like.